Hi everyone, welcome back to Array series. Hope you are doing good. This is Mahesh. In this video, we are solving Leetcode problem number 229, which is majority element 2. So let us look into the statement of the problem. So it says, given an integer array of size n, find all elements that appear more than n by 3 times. And if you look into the constraints, the length of nums array ranges between 1 and 5 into 10 raised to 4. And if you see any element in the nums array will range between minus 10 raised to 9 to 10 raised to 9. Okay, with that, let us switch to editor. So basically, this is the continuation of the earlier problem which we solved, majority element 1. So if you have not watched that video, I will leave that link in the description box and you can go through that video and you can come back and watch this video. So with that, let us try to understand the problem. So here they have given this particular nums array. Okay, it contains some elements. Okay, and if you see, the length of this particular array is 11. Okay, now we need to find element that appears more than n by 3 times. So here n by 3, in the sense it will be 11 by 3, which will be 3 point something. Correct, right? So it will be 3 point something. If that is the case, then we will have to find numbers that appear more than 3 point something, means that appears at least 4 times. That appears at least 4 times or more than 4 times also is fine. So with that, if you look into this array, so we have 1 appearing once, twice, thrice, and 4 times. So since it is appearing 4 times in the array, so this is one of the numbers that our Leetcode expects as an answer. Then if you see 2 appears once and twice. So it means it is appearing less than 4 times. So it means this is not the intended number. Now let us look into the other number. It appears 3, 4, 5 times. So basically 3 appears 5 times. So it means 3 will also be part of our answer here. So we will have to return 1, 3 as part of this particular problem. Okay, so that is what is the problem statement says. So with that, we have already seen the constraints. Maybe what you can do, you can pause the video for a second. You can think for any possible solution. With that, now let us try to understand what is the idea behind this particular problem. So when interviewer gives this problem to us, he expects us to solve in O of n time complexity and O of 1 space complexity. Okay, so how to do that? So before that, let us look into the brute force solution, which is an extreme naive solution for this particular problem. So here what we need to do, we need to take number and we need to count how many times it appears in the entire array. So first I'll start with 1, then I will scan throughout the array. So 1 appears 4 times, then it is our intended number. Then I will start with 2, then I will scan the entire array. Now if you see, 2 appears twice, so it is not it is not part of our answer. Again I will check the next number. I will iterate over the array. So again I will count 3. So it is more than 4, more than 3 point something. So n by 3 times. So it means that is also part of our answer. Correct, right? So this way, what we can do, we can iterate over each element and we can count it and we can try to come up with the answer. So let us try to do that. I will try to write the pseudocode for that logic. So if you see, I stand at one number, then I will scan all the elements. Correct, right? Then what I will do, I will stand at the next number. Again, I will scan all the elements. So it means one pointer is kind of slow pointer and another pointer is kind of fast pointer. I mean, not exactly, but we need two for loops basically here. That is what I'm trying to say. Okay. So now what I will do, I will use two for loops as I said. So initially n will be our nums dot length. Okay. Then what else we need? We need our result, right? So I will say the result is our empty array. Okay, then what I will do, I will use for loop for I equal to 0 to n minus 1. Then I will take another loop for j equal to 0 till n minus 1. Okay, so this is basically our number, and then we will scan using the next for loop. So now what I will do, I will check if nums of I, if it is equivalent to nums of j, then I need to increment the counter. So before the second for loop, I will say count equal to 0. Then if this is the case, I will increment my count. Okay, then at the end of the second for loop, once the scanning happens and once we get the count, I will check if my count is greater than n by 3, and also this particular value nums of I should not be part of our result array. If it is already considered, then we should ignore that. So what I will say, I will remove this result dot contains, so it should not be contains, not of result dot contains our nums of I. Then what I will do, I will say result dot push. So this is basically in JavaScript. So in Java, what we do, we say result equal to new int something like this. Then what I will say, result of index. So basically I will take a variable index equal to 0, then index plus plus equal to nums of I. I will do like this in Java. So push of nums of I. Okay, so with this, finally what I will do, I will return my result. Okay, so this gives us the numbers which appear more than n by 3 times. Now if you see, we are using this particular for loop, correct? Then again we are using the second for loop. So it means we try to iterate over the array, like for each element the entire array once. So there are n elements and we iterate over n times for each element. So our time complexity becomes order of n square, order of n square. Okay, and if you see the space complexity, since we are not using anything extra here apart from this particular result array, it is very minimal one. Max to max it might contain two numbers, so it is almost of order constant space complexity, so we can say order 1. Okay, this is extreme naive solution. But if you see, we have this particular time complexity which is of order n square, right? So we need to improve this. So how to improve this? Then what is the better solution for this one? So now whenever we say the occurrence of any number, then what comes into our mind? So basically the counter, right? Counter in the sense map. So map will keep track of the occurrences of each number. So let us try to use the hash map. So I will use hash map. So basically what I will do, I will take a hash map, assume this is our hash map. Okay, so I will copy this array. So now if you see, I will start with the first number. So this is appearing for the first time. So I will say 1 appears once. Next, I will move to next number. So 2 appears once. I will move to next number. 3 appears once. Okay. Then I will move to next number 1. So 1 is already there. So I will just increment the count to 2. Then I will go to 2. 2 is already there. So I will increment the count to 2. next 1, so I will increment it to 3, then again 1, I will increment it to 4. Okay, next we get 3, so I will increase it to 2, again I'll get 3, so I'll increment it to 3. Now if I go to next number, again I'll get, so I'll increment it by 1. So again I will go to next number, it is 3, so I'll increment it. Now if I try to move, it will move out of the array. So if that is the case, now we get the count of each number. So basically that is the occurrence of each number. Now if you see the map, our 1 appears 4 times, which is greater than n by 3, and our 3 appears more than n by 3 times, which is more than 4. So 4 or more than 4 will be considered for our answer. So these two numbers we will push it to result array, then we will return back those elements. Okay, so with that, let us try to write the pseudocode. Now again, what we need, hash map, hash map, hash map in Java and map in JavaScript. So I will say counter equal to new hash map, and we need to specify the types, something like this in Java, hash map of integer comma integer. So counter equal to new hash map. So something like this we need to do in Java. So in JavaScript it is simply map counter equal to new map. Okay, so with that, now what I will do, I will use for loop for I equal to 0 to n minus 1. Okay, so what I will do, I will try to counter dot set in JavaScript and put in Java. Then I need to pass the key. Key will be our number. So I will say nums of I, then comma, we need to pass the count. Okay, so count will be, if there is something already there in the map, then we need to consider that, or else we will have to give 1 to it. So what I will do, I will say counter dot get in JavaScript, get or default in Java. So I will say nums of I, and I will pass the default number. So if there is number, it will give the count for this particular number. If there is no number in the hash map, then it will give, it will give us the default value 0. Then to it, I will add 1. Okay, that way we will increment it. So this way we count the numbers. So counting is done now. Now what we need to do, we need to iterate over this particular hash map. Then we need to check each number if it appears more than n by 3 times, and then we will add it to our result array. So if I want result array, I will take my result array something like this. This will be an empty result array. Okay, then what I will do, I will use for loop to iterate over the map. So this is just a pseudo code, so I'm not using the proper syntax. You can we will see that later when we are writing the code. So basically I will take key value pair, I will iterate over key value pair of our counter dot entries. Okay, so entries, this will give us each key value pair one after the other, something like how array gives. Array will give a single value, but this will give us key and value pair. Okay, so then what I will do, I will check if my value, if it is greater than n by 3, then what I will do, I will say result dot push, or something like result of index plus plus nums of I. Okay, so this way it will add the element into the result array. So then I will close this loop. Then I will simply return my result array. So if you see, this particular for loop we used to iterate over the array and we counted the occurrences of each number. Now the second for loop we used to check if the count is greater than n by 3. If that is the case, then we pushed that particular. So basically this should be key, not nums of I, my bad. So this one, it will check if it occurs more than n by 3 times, then it will simply add it to our result. Okay, so with that, now what is the time complexity? So if you see, we are iterating over the array once here, then we are iterating over the map once. So in worst case, so our time complexity will be of order 2n. Okay, ideally this map, it won't contain n values, it will be lesser, normally 2 to 3 values. But in worst case, in some arrays, I mean, if all the numbers are unique, that time, I mean, it can go till n. That's why it is of order 2n, and that is considered as order of n only. Then if you see the space complexity, we are using our hash map here. That's why it is of order n in worst case. Okay, so this is the extra space that we are using to solve this particular problem. Okay, with that, let us try to execute this answer.
So let us create a hash map of integer, comma, integer. Let's call it as counter equal to new hash map. Okay, then what we will do, we need a result array, right? So we will use a list of integers, then we will call result equal to new array list. Okay, then after this is basically to store our values, result values. Then after this, what I will do, I will use a for loop. So int num colon nums. So we will iterate over each number. Then we will say our counter dot put here. So put, then we will say num comma, again we will check if counter has that value. So get or default, then we will pass our key as num and default value as 0. If there is value, it will take that value, basically the count, or else it will consider default value 0, then it will add 1 to it. This way we will do the counting. Then after this, we will use for loop. So we will iterate over each key value pair. That's why I'm using map.entry integer comma integer. So each entry we will try to iterate. Then what we will do, so we will have to check if my entry dot get value, if it is greater than n by 3, then we need to add it to my result array list. Okay, so result dot add of so there is a spelling mistake, so I'll copy paste it better. So entry dot, now we need to store the key. Okay, because that is what is the intended element for us. So with this, finally what we will do, we will return our result array list. With that, let me run and see. So there is some issue. Let me check what is that. Okay, so basically we have to declare int n equal to nums dot length. I missed that. So with that, let us run. So it got accepted. Now I will submit it. So if you see, our solution got submitted successfully. So if you see, this particular algorithm takes extra space, correct, right? Which is O of n, which is this particular hash map. So if we want to further improve our algorithm, then we will have to eliminate the usage of this hash map. So how to do that? So for that, we need to use Boyer-Moore's voting algorithm. Okay. So if you have seen my previous video, in that I have already explained how this Boyer-Moore's voting algorithm works. So basically, I mean, it will try to find the candidate. Assume there is a voting contest that has happened, and in that, I mean, there are two contests who have contested for the election. In that case, we try to get the majority candidate by getting his relative votes. Say for example, there is candidate 1 and there is candidate 2. If candidate 1 gets out of 10, if he gets like 6 votes, then this will get 4 votes, correct, right? What is the relative difference? That is, candidate 1 will be leading with 2 votes, correct, right? So this is when in the majority one problem, because there we were checking for more than n by 2 votes. So if more than n by 2, if there are 10 votes, then for 10 by 2 it will become 5. If it has to be more than n by 2, then it has to be 6, right? I mean, he should get 6 votes, then only he will be considered as the winner. So in the similar case, now if you see this particular problem here, there will be candidate who will be, or there will be candidates here basically, because if a particular candidate gets more than n by 3 votes, then he is considered as winner according to this problem. So in this example, there are 11 votes, right? So out of these 11 values, if you do 11 by 3, it is somewhere around 3 point something. So it means it has to be greater than this value. So it means at least 4 votes that candidate should get. If you see, there are 11 votes, right, or 11 values here. So if you subtract 4, then remaining will be 7, correct, right? Again, with 7 vote, there is a possibility one more candidate can get 4. So remaining will be 3, correct, right? Now, if you see, we will get 2 candidates here. So that is what is the core intuition that we need to understand. We will get 2 candidates who can become the winners here. So if we know that concept, then easily we can solve this particular problem. So now before solving this, let us try to understand one more concept. Say for example, we have candidate 1, we have candidate 2 and we have candidate 3, correct, right? Assume we got 1 vote for candidate 1. So candidate 1 is leading, okay? Again we got one vote for candidate 2. Now candidate 1 and candidate 2 are leading with 1 votes, correct, right? Because C3, candidate 3 has still 0 votes till now. So now assume C3 also gets 1 vote. So if C3 also gets 1 vote, here nobody is leader here. I mean, nobody is leading with any votes. So their relative counts will be set back to 0, correct, right? Because all are in the same situation. Nobody, I mean, we cannot declare anyone as winner. So assume now after this, again, our C1 gets 1 vote, then he gets increased. Now he comes to lead. Now assume C3 gets 1 vote. So then if you see, the situation changed. Earlier C1 and C2 were the winners, but now if you see, C1 and C3 will be the winners. So we will use this concept to come up with the solution for this particular problem. So basically we are trying to find the relative votes with which a candidate wins. Okay. So now we understood there will be 2 candidates, right? I mean, if the votes are, I mean, vote should be greater than n by 3. Then what we will do, we will take candidate 1 he is our first winner candidate, and we will take candidate 2. He is our second winner candidate. We will keep on updating. So sometimes it might be candidate 1 who is leading and candidate 2 who is leading, but in some other case maybe C1 and C3 might be leading. In some other case C2 and C3 might be leading. So we will keep on updating who are the leading candidates. So that way we will finally get who will be the leading candidates. Okay, so now along with this I also need the relative count for candidate 1. So that will be count 1, and for candidate 2 it will be count 2, correct, right? So now let us start. I will start with 1. So now if you see, initially the count 1 and count will be 0, 0. So if count 1 is 0, first thing is you first check whether count 1 is 0 or not. So before that you can also check, basically these values will be null. Okay, the order should go as I say. So first you check whether this particular value, it matches with this particular candidate. Now it is null, so it means it is not the candidate. So if that is the case, then you check whether the next candidate is this particular value. That is also not right. Now you check the first count. So basically first we need to check the first count. Okay, if you check the first count, it is 0. So it means the probable candidate 1 would be this one. So now what I will do, I will assign this particular value to candidate 1. So he might be the winner. So we don't know at this point of time. Now if 1 appears, then his count should increase, right? He is getting 1 vote. Okay. Now after that I will move to next value. So now I get 2. So he is not equal to candidate 1. So if that is the case, then we will have to check with candidate 2. Candidate 2, he is not equal to candidate 2, but count of 1 is 1. So it might not be candidate 1. So count of 2 will be 0. So it means now we got a new candidate 2 who is leading. So we will take that 2 and we will update here. So I will take 2 as my candidate 2 and I will update his count to 1. Okay. Now if you go to next candidate, he is 3. So if he is 3, you see this scenario is appearing. So now it means I need to reset the votes of candidate 1 and candidate 2, correct, right? Because this 3 is not candidate 1, this is not candidate 2. So that's why what I will do, I will reset their count to 0, 0. Okay. Next what I will do, I will move to next number. Now if you see, we get 1. So candidate 1 is 1. So I will increase the count. Okay. Next I will move to next number, which is 2. So now if you see, it is candidate 2. So I will increase its count by 1. Okay. Now what I will do, I will move to next number. Now I get 1. So it is candidate 1. So I will increase the count to 2. Now I will go to next number. Again it is 1. So I will increase the count to 3. Okay. Next I will go to next number. Then if you see now, it is 3. So it is a different candidate. He is not candidate 1. He is not candidate 2. Which is 2? 1 or 2. So it is not 1. It is not 2. So it means we will have to decrement both the counts. So now what I will do, I will decrease it to 2 and I will decrease it to 0. Okay. So now after this, I will go to next number. I will go to next 3. Now if you see, he is not candidate 1 and he is not candidate 2 also. Now you check the count 1, it is 2. So now if you check count 2, it is 0. So it means now we are getting a new candidate who is leading. So candidate 2 will be this 3. So now what I will do, I will change this to 3 and I will update his count as 1. So he is relatively leading with 1 vote now. Okay. So next I will move to next number, which is 3. So it is candidate 2. I will increase the count. I'll go to next number. Again, I will increase the count. So now after processing last element, I'll move out of the array. So now if you see, these are our probable candidates. Candidate 1 will be 1 and candidate 2 will be 3. So then after this, we should make sure they really appear more than n by 3 times. Now what I will do, I will simply reset these counts to 0, 0. So I'll start again. This is 1. So it means it is our candidate 1. So I will increase count 1. Now I will move to 2. So this is not candidate 1, this is neither candidate 1 nor candidate 2, which is 3. So that's why I will skip and I will move next. This is 3, so I will have to increase candidate 2's count. So I will increase. Next value is 1, so I will have to increase this count to 2. Next value is 2, so this is neither candidate 1 nor candidate 2, so I will skip and I will move. Next, if you see candidate 1, I will have to increase its count. Again, we have candidate 1, so I will increase the count. Again, if you see, we are not getting 1, now this time it is 3, so it is basically our candidate 2, so I will have to increase the count of candidate 2. Next, again 3, so it is 3, again 3, so I will increase it to 4, again 3, I will increase it to 5. Okay, finally from this you can make sure the count 1 of candidate 1 is 4, which is greater than n by 3. So it is greater than 3 point something. Okay, so now if you see candidate 2, the count is greater than n by 3. So now you can simply return these two values, 1 and 3. Okay, so this is how we need to analyze this particular problem's solution. Okay, with that, let us try to write the pseudocode for this one. So our n will be nums dot length. Okay, now after this I will take candidate equal to null and count 1 equal to 0. Then candidate, this should be 1, this should be 2, so equal to null and count 2 equal to 0. So with this, now I will iterate over the array for I equal to 0 to n minus 1. So I will basically 0 to n, I will say. So from 0 to n minus 1, I will say simply n minus 1 because we will iterate from 0 to n minus 1. Now what I will do, I will check if my nums of I, if it is equal to our candidate 1. So what we will do, we will simply increment count 1, correct, right? If this is not the case, I will use else if. If it is not the case, I will check this with my candidate 2. Okay, so if it is equivalent to candidate 2, then I will have to increase the count of candidate 2. So I will do count 2 plus plus. Okay, then what I will do, if this is also not the case, then in the else if, what I will do, I will check my count 1 equal to 0. If my count 1 equal to 0, I get a new leading candidate 1. So I will say my candidate 1 equal to nums of I, and I will say count 1 equal to 1. Okay, if that is also not the case, I will check else if my count 2 equal to 0, then what I will do, I will say my candidate 2 equal to nums of I, and I will set its counter count 2 equal to 1. Okay, because we are getting new candidate, new second leading candidate. So if this is also not the case, then the candidate is something different. So that time we will have to simply decrement count 1 and also count 2. Okay, this is our else. Then once this is done, now we need to make sure our whatever candidate 1 and candidate we get, they are having the required count. So now what I will do, I will reset my count 1 to 0 and count 2 to 0. Okay, then I will use for again I equal to 0 to n minus 1. What I will do, if nums of I, if it is equal to my candidate 1. Then what I will do, I will say count 1 plus plus. Okay. I will use one more if statement. If our nums of I, if it is equivalent to candidate 2, then I will simply increment count 2 plus plus. Okay. Then finally what I will do, I will take a result array. So result array will be empty array initially. Then what I will do, I will check if my candidate 1 count, sorry, basically we should take the count. If my count 1, if it is greater than n by 3 here, not 2, then we will say result dot push or result dot add result dot push of candidate 1. So this is JavaScript. In Java, you basically take a index equal to 0, then you say result of index plus plus will be your candidate 1. Okay, this is how we need to do. Now I will also check if my count 2 is greater than n by 3, then again same result dot push of candidate 2. Okay, finally return our result array. Okay, if you see, we do this in single pass. We do this in single pass and we are not using anything extra. So we are using few variables. Apart from that, we are not using anything extra. So our time complexity will be of order n and space complexity will be of order 1. So this is how we effectively use Boyer-Moore's voting algorithm here. So with that, let us switch. Now remove this part. This is not required. We also want to remove this hash map. Then let's keep the result list. So now what I will do, I will use for num colon nums. So I will basically iterate over the values in the nums array. So it will be int num. So before this, what we need integer candidate 1 initially assigned with null and also candidate 2 initially assigned with null. Okay. Now we need the counters. So count 1 equal to 0. Okay. Then count 2 will also be 0. With this, now what we will do, we will check if our number is not equal to null, and if it is equal to our candidate 1, then what we need to do, we need to increment the count 1. So I will do that. Next, I will use else if my number is not null and if it is not candidate 2, then if it is candidate 2, then we will have to increment our count 2. If that is also not the case, in the next else if statement, I will check if my count 1, if it is 0, then we got a new leading candidate 1. So I will copy paste candidate 1 equal to our number and our count 1 will be set to 1. Okay, I will copy paste this line, repeat the same for count 2. So I will change this candidate 1 to candidate 2 and this will become our count 2. Finally, in the else part, if it is a different candidate, then we will have to decrement count 1 and also decrement count 2. Okay, so this is how we count the votes. Then in the second pass, we will have to verify. So for that, I will first reset my count 1 to 0 and also my count 2 to 0. Then after resetting, I will use a for loop again, num colon nums. I will have to use int here. Okay. Then I will check if my number, if it is equivalent to candidate 1, then I will increment my count 1. Next, I will do that for candidate 2 as well, and I will increment count 2 in that case. Okay. Finally, what I will do, I will check if my count 1, if it is greater than n by 3, then I will say result dot add of candidate 1. Okay, I will repeat the same for candidate 2 by checking the count. Okay, with that, finally, I will return my result. Okay, with that, let's try to run and see. Hopefully, there are no spelling mistakes. There is some issue. It says it is not null. So instead of number, I should check the candidate because we need to validate whether candidate is not null. So similarly, here it is for candidate 2. That's my bad. And with that, let's run. Now, if you see, there is one more issue. I also need to make sure this candidate 1 is not null here. Candidate 1 and candidate 2, that is what it is complaining. So I will copy these and add it here. Because if you see, our nums array is of int type, but our candidate 1 and candidate 2 are integers. So because of this primitive types, I mean, we will have to first check these values, then we will have to try to add them. So that is what I have done the modification. With that change, I will run this. It got accepted and I will submit this solution. Okay, our solution got submitted successfully. I hope I was able to explain this concept well, and I hope that you understood it well. If that is the case, please add that as a comment in the video, and also consider subscribing to my channel, and also like the video, share this with your friends, and if you have any queries, you can add that as a comment. Thanks for watching the video.